What's up, guys? Welcome back to Math Tutorials. Today we have some more AP Calculus BC practice. So this one is a Taylor series no calculator question. Um, if you are in the same math class as me and you're wondering why I didn't do any of the other three problems, it's because they were all calculator questions, and those are kind of awkward to show on a video like this. That was the whole reasoning. But let's just get into this problem. So the Taylor series for a function f about x equals 1 is given by the sum n starts at 1, goes to infinity, of negative 1 to the n plus 1 times 2 to the n divided by n times x minus 1 to the n. Great. And converges to f of x for x minus 1. Absolute value is less than r, where r is the radius of convergence. Okay, so cool. Find the value of r. So basically they're saying find the radius of convergence. So of course to do that, we do the ratio test where we set up this with, well, all right, so we set up the absolute value, and we're going to have basically this, but with n plus 1 instead of n, divided by this still just with n. So basically, this with n plus 1 divided by this. And of course, this is limit as n goes to infinity. So I'm going to replace all the n's with n plus 1 and put that in the numerator. So we'll go negative 1, n plus 1 plus 1, of course, n plus 2. And then 2 to the n, 2 to the n plus, okay, n plus 1, and then x minus 1 to the n plus 1, and then we will divide this by n plus 1. I'm going to put this over here because we're going to have all the terms kind of lined up, not terms, but we're going to have all the things kind of line up, so it's easier to see what cancels. And then we're going to divide by this, by what's already here. And so, of course, anything in the numerator here, we put in the denominator, and anything in the denominator, basically this is going to go in the numerator because dividing by a fraction is the same as multiplying by the reciprocal. Anyways, so negative 1 to the n plus 1. Line that up with the other negative 1 times 2 to the n. Line that up with 2 times x minus 1 to the n. And then divided by n. And we're going to put this in the numerator, which is why I put this thing kind of off to the side. So absolute value of this then goes to infinity. This is going to have to be less than 1. Of course, that's the ratio test. All right, so now we can kind of just go along and see how, how these four things all interact with each other. So negative 1 to some power divided by negative 1 to some power to that same power minus 1, basically. Well, let's say this ends up being even. That means that this ends up being 1, and then this ends up being odd, which means this is negative 1. So it'd be 1 over negative 1. Now, so it'd be negative 1, right? Now, if this top part ends up being odd, then this ends up being odd, so that's negative 1. Then this ends up being even, right? Because even odd switches every time. So this is going to be 1. So it's going to be negative 1 over 1. So basically, this kind of unit right here, no matter what, it's going to equal negative 1. So we have same thing here, lim n infinity. But this is just going to be negative 1 no matter what. 2 to the n plus 1 divided by 2 to the n. Of course, it's just going to be 2. Kind of similar idea here. X minus 1 to the n plus 1 divided by x minus 1 to the n is just going to be x minus 1. And then this, we can think of this part multiplying the top and bottom by 1 over n, kind of, which gives us 1 over 1 plus 1 over n. And of course, as n goes to infinity, that's going to equal 1. So I'm not even going to write it because it'd just be times 1. So absolute value, that is less than 1. So now we can kind of get rid of this, I think, this limit, because we don't even have an n in there anymore. So we're really just saying negative 2 x minus 1 less than 1. And so remember, we wanted just this part in the absolute value. So what we're going to do is get rid of the absolute value and say negative 2 x minus 1 is less than 1, and then negative 2 x minus 1 is greater than negative 1, because that's how you get rid of absolute value, right? You have to split into 2. So then we have, okay, x minus 1 is greater than negative 1/2, and then x minus 1 is less than positive 1/2. So we have this x minus 1, and it seems like if you kind of think of it as being centered at 0, it can go up to 1/2, and it can go down to negative 1/2. Now, we don't know if these endpoints are included or not, but to find the radius of convergence, you don't actually know. If it said find the interval of convergence, then you would have to check these endpoints. But for this, we don't care at all. So this is negative 1/2. So you can see this radius, if you kind of think about it as, okay, wow, as kind of a circle. Okay, just pretend it goes through both points. Sure, Pokeball. Anyways, you can think of the radius as being this distance right here, or, this distance right here. And so the radius is going to be 1/2. So that r will be 1/2. So to go back up here, find the value of r, it will be 1/2. All right. Find the first 3 non-zero terms and the general term of the Taylor series for f prime, the derivative of f, about x equals 0. So what I'm going to do is find the first 3 non-zero terms and, well, actually, I'm going to do the first 4 non-zero terms and the general term of just this. And then I can find the derivative of that from there manually. So I'm going to plug in 1, then plug in 2, then plug in 3, then plug in 4 for this. So if I plug in 1, this ends up being 1. 2 to the 1 divided by 1 is just 2. And then x minus 1 to the 1. So that would end up just being 2x minus 1. Okay, and then it's going to alternate, right, because of that negative. And then that's going to be 2 squared, so 4 divided by 2 is still 2. And then that'll be 2x minus 1 squared. And then again, it'll alternate. If I go 3, 2 to the third, that's 8 divided by 3. So 8/3, x minus 1 to the 3. And then, of course, alternate again. That will be 2 to the 4 divided by 4. So that'd be 16, right? Yeah, 16 divided by 4, which is 4. And then, of course, x minus 1 to the 4th. So in general, well, we already know the general term. It's just this. So the general term, we'll say, is negative 1, n plus 1, 2 to the n over n, x minus 1 to the n. Wow, don't know what just happened. Okay, so that's the general term, and this is all for f, right? Plus dot dot dot. All right, so this is f. Now we want, I'm actually gonna write this on the other side. This is f, but we want f prime. So let's take the derivative of each of these. So the derivative of this, which is 2, we're gonna do the, I mean, you could do the chain rule technically, but the derivative of the inside is just 1, so you can kind of just treat it as if it's just x in there. Then you do the power rule, so that'd be minus 4 x minus 1, and then that would be plus, this goes down, that kind of cancels out, so that would be 8 x minus 1 squared. Oh, I guess I didn't need the first 4. I kind of thought one of them would disappear, but that's not the case. So yeah, let's just kind of describe this. So that's the first 3 terms, and then plus the general term, dot dot dot, of course, is going to be negative 1 to the n plus 1. So in general, right, it seems like we're still going to have some sort of power of 2 type thing happening here, right? So 2 to the n, but this n is going to be multiplied, and it's actually going to cancel out with this n. So really, we're going to have no n there, and we're going to have x minus 1 to the n minus 1. So now let's think, does this work as a general term? Let's check the first term. You would plug in 1, so that'd be 1, 2, that'd be 0, so this whole thing would be 1, so it would just be 2. Checks out. And then if you plug in 2, that'd be negative. that would be 4, negative 4, and then x minus 1 to the 2 minus 1. Checks out, and then one more check. If this is 3, that would be even, so that would be just 1. That would be 8, and then that would be 2. So checks out. So this is the first 3 terms of the derivative and the general term. So that's our answer. The Taylor series for f prime, which is what we just did, about x equals 1, found in part B, right, is a geometric series. Find the function f prime to which the series converges for absolute value of x minus 1 is less than r. Use this function to determine f. So this is a geometric series. So what they're telling us, find the function f prime to which this series converges. So they're basically saying what is the actual function that produces this Taylor series. Now we know it's a geometric sequence, and we have a way of summing up, because if we do the sum of this whole infinite series, then that is basically the function, right, that we're trying to find. And we have a way of summing a geometric series, right? It's a over 1 minus r. So first term over 1 minus the ratio. Now what's the, so we just have to find the first term and the ratio of this geometric series. So we know that the first term is 2, so a equals 2. And the ratio, what is it being multiplied by each time? Well, it seems like you're multiplying by 2 to get the 4, but you're also multiplying by x minus 1, right? Because the 2 is increasing in power each time, and so is the x minus 1. So r is 2, x minus 1. So this is 2 over 1 minus 2, x minus 1. I'm going to simplify this a little bit to be 2 over 1 minus 2x, yeah, plus 2, right? Yeah, I think so. It feels wrong. Hold on. Let me check the answer key. This is very important. You gotta make sure what you're doing is correct. Um, right. So my mistake is that this is not r. R is actually negative because it alternates each time, and that's where that alternating has to come from. So this would be negative, so this would really be plus. So let me get rid of this. All right. So yeah, the ratio is negative, which produces the alternating, which means that, right, that gets converted to a plus. This is still the same. But then we have 1 plus 2x minus 2. So then we have that f prime is equal to, right, because f prime is an infinite series, and this is the sum of an infinite geometric series, 2 over 2x minus 1. Okay, so that's part of our answer, I believe. Find the function f. Okay, so we did that, but now we need to use this to determine f. So we have f prime and we need f. What did that sound like? To me, that sounds like integration. So we need to find the integral of 2 over 2x minus 1. Now, luckily, this is in a form that I recognize, which is integral of u prime over u du equals ln u. All right, so here we have uh, we have 2x minus 1 on the bottom, and we have the derivative of that on top. So basically, we have this kind of setup here, which means we can kind of just convert it to this. So basically, we can say that this equals natural log of 2x minus 1, right? And that's, oh, and then we have to find c, right? Because yeah, we have to do plus c, of course. I'm sure almost every calculus student has missed a point on a test for forgetting the plus c. Um, do we have information here to tell us what c is? Well, we have this, right? We have the actual function right here. So maybe we can do something with that, right? Let's see. We know that if we plug in 1, we have to get 0, right? Because This is that function f. So this is, by the way, this right here, this whole thing, that thing that we did a long time ago, is the same as this. So for this function, you see that if we plug in 1, the x minus 1 is going to be 1 minus 1 equals 0. So that's going to cancel out every single term that has the x minus 1 in it, and that happens to be every single term. Sometimes you'll have like, you know, a 1 plus out front or something like that. But for this, every single term has x minus 1. So if you plug in 1, you have to get 0. So if we plug in 1, right, f of 1 equals 0. So we're saying natural log of 2 times 1 minus 1 plus c equals 0. Now this simplifies, of course, to 2 minus 1. So natural log of 1 plus c equals 0. But if you remember how natural logs work, the natural log of 1 is 0. So 0 plus c equals 0, and of course c equals 0. So basically, we didn't have to worry about it. So f simply equals this, which I'll rewrite because we just went through this process. So f equals natural log of, what did I say? 2x minus 1. And that is what we wanted. So, hope you enjoyed this video. Of course, if you have any questions about the process or other completely unrelated questions about calculus, feel free to ask me in the comments. That's what I'm here for. But yeah, until next time, see ya.